Hi, I am Chae-Yeon, a second-year master student at Posttech, South Korea. I am excited to present our work, Perceptually Accurate 3D Talking Head Generation, New Definitions, Speech Mesh Representation, and Evaluation Metrics. This is joint work with Hyunbin, Eungi, Seongbin, Sukyung, and Professor Oh. Speech-driven 3D talking head generation is a task of generating 3D face meshes aligned with given speech. For example, given a speech signal, the model generates 3D face meshes that articulate the given speech.
She had your dark suit in greasy wash water all year.
To provide users with a more realistic experience, it is crucial that lip movements are synchronized with speech from a human perception perspective. Then what defines perceptually accurate lip movement given a speech, and how can we enhance this accuracy? In this work, we first define three essential criteria for perceptually accurate lip synchronization. Second, we construct a speech mesh representation and adopt it as a perception loss to enhance perceptual accuracy. Finally, we introduce three novel evaluation metrics to assess perceptual quality. To start with, we define three criteria inspired by findings on human audiovisual perception. First, temporal synchronization. Humans are sensitive to temporal asynchrony between speech and lip movements. Second, lip readability. Humans expect visual lip movements to match the spoken phonemes. Third, expressiveness. Humans anticipate proportional increase in lip movement as the speech intensity increases. Temporal sync and lip readability criteria have been discussed in previous studies. However, to the best of our knowledge, expressiveness has not been discussed before. Why should we consider expressiveness? Through our human study, we reveal intriguing findings on expressiveness. We conduct a human study by presenting 3D talking heads with varying lip and speech intensities. The results show that users prefer positive correlation between two intensities. Furthermore, we conduct an A/B test comparing temporal versus expressive sync. As shown in this table, users prefer the expressively synchronized sample despite 100 millisecond asynchrony. It suggests that humans may prefer expressive sync over strict temporal alignment. This insight highlights the need to enhance all three aspects for perceptual realism in 3D talking heads. Then how can we enhance perceptual accuracy? We hypothesize that a desirable representation space exists to meet the three criteria we define. As illustrated in this figure, the desirable representations are sensitive to temporal sync, the same phonemes are clustered, and follow a certain pattern as speech intensity increases. Motivated by this hypothesis, we develop a speech mesh synchronized representation and adopt it as a perception loss to improve the accuracy of existing models with respect to these three criteria. Now we explain the pipeline of our speech mesh synchronized representation. In stage 1, we learn an audiovisual speech representation using 2D talking face dataset to capture the correlation between speech and lip dynamics. We extend the integration of masked autoencoder and cross-modal contrastive learning. We observe that this learned audiovisual speech representation space already possesses the desired properties we pursue. It demonstrates temporal sensitivity, distinct clusters according to phonemes, and directional trend as intensity increases from lowest to highest. Motivated by this, we transfer its desirable lip sync properties to the speech mesh representation. Therefore, in the next stage, we freeze the pre-trained speech representation and use it as the anchor space to learn a speech mesh representation. We align 3D facial motion embeddings with the anchored speech representations. After constructing the speech mesh representation, we adopt it as a plug-in perception loss to enhance the perceptual accuracy of the 3D talking head model. It ensures that the generated lip movements are perceptually well aligned with the speech. We define our perceptual loss with the contrastive loss, with some speech-anchored loss and the mesh-anchored loss across L selected encoder layers. In the experiment, we construct two large-scale speech mesh benchmark datasets, LRS3D for training the speech mesh representation, and WIDS3D for enhancing the expressive power of 3D talking heads. To obtain pseudo-ground truth 3D face meshes, we leverage an off-the-shelf 3D face reconstruction model. Now we present the experimental results. Does our perceptual loss improve lip sync? We use three 3D talking head generation models to evaluate the effectiveness of our perceptual loss. Our perceptual loss consistently improves all three aspects in all the baseline models, which means that the loss can be utilized as a plug-in loss to enhance the perceptual accuracy of lip synchronization. Here we show a qualitative comparison.
How many endemic floral species do forests harbor? How many endemic floral species do forests harbor?
Shaving cream is a popular item on Halloween. Shaving cream is a popular item on Halloween. Waterproof galoshes are very useful in Seattle. Waterproof galoshes are very useful in Seattle.
Next, can we unlock the expressive power of 3D talking heads? To study this, we examine the expressiveness of the base models using mid-3D dataset, which includes 3 intensity levels. As shown in the table, models trained only on Bocaset showed limited expressiveness due to its smaller scale and intensity range. When we integrate mid-3D, it improves expressiveness but degrades other lip sync criteria. To counterbalance this, we leverage our perceptual loss, which effectively mitigates the degradation while improves expressiveness. Here is the qualitative comparison.
In many of his poems, death comes by trade, a strongly evocative visual image. In many of his poems, death comes by trade, a strongly evocative visual image. In many of his poems, death comes by trade, a strongly evocative visual image.
One even gave my little dog a biscuit. One even gave my little dog a biscuit. One even gave my little dog a biscuit.
She had your dark suit in greasy wash water all year. She had your dark suit in greasy wash water all year. She had your dark suit in greasy wash water all year.
In conclusion, we identify 3 essential criteria for perceptual 3D talking head. To enhance perceptual accuracy, we construct a speech mesh representation space. We uncover its emergent properties desirable for perceptually accurate lip sync. Based on this, we propose a plug-in perceptual loss to the existing 3D talking head models and demonstrate consistent improvements across all 3 criteria. Lastly, we introduce evaluation metrics specifically designed to assess each aspect of perceptual quality. Thank you for your attention.